I want to thank HGS for inviting me here, even though I had to send a lot of emails to Scott and to Jim, but I really do appreciate this opportunity. And I want to thank you for taking the time to come out and hear what I have to say. So let's see. Yep, that's where we'll go. So why am I here, and why did I want to make this presentation to the Houston Geological Society? Well, last month I had, no, I can't do that, so I can't clap my hands. The first paper that addresses anthropogenic global warming, AGW, that peer-reviewed in the AAPG Bulletin was I was the author of that paper. But it was a 2-year effort, actually more than 2 years. I had to write it and then submit it and then resubmit it. And I know we have one reviewer in the audience. It greatly improved over that 2-year period when I first submitted it. It was much more rigorous, balanced, and all that. So I do thank all the reviewers that took the time to an effort to do that. And it is available. All you got to do is, if you're not a member of AAPG, why not? They need the membership. I think so. But also, if you're not, you can email me and I can send you a copy of the paper. Okay, so what am I going to be talking about? I'm going to be talking about how the, especially natural gas industry, can be part of the effort to avoid 2 degrees by getting down 80% lowering of emissions by 2050. So that is the goal. That's one of the goals of the COP21. Now then it's stay below 2 degrees, or if possible go to 1.5 degrees, but stay below, that's Celsius. But we're just going to start with the 2 degree, and if we can do that, then we can work for better. Now, one of the things that I showed in this is one way of doing it, is just uniform reduction in oil, gas, and coal. That's not really a very sane way to do it. What I'm going to really emphasize more is I came up with a scenario, and I'm not a modeler, as my bio pointed out. I'm a research geologist, or I was a research. I'm still writing papers. I looked at rocks, tried to avoid numbers as much as possible. I looked at rocks, but I'm interested in climate change. I know it's real, so I was interested in pursuing this particular examination. So what I'm showing here is a way to get to that 2 degrees, and I'm going to show you in this particular scenario, one hypothetical scenario where you could actually get to that and still stay below 2 degrees. I'm also going to show, and this is not in my paper, but a balanced approach that would incorporate using natural gas is better than a drastic approach. I'm sure you've heard of the Green New Deal, but actually you can get to the same place with a lot less money, so you can spend the money on something else. Climate change. I'm not going to talk about climate change. I think all of you believe in climate change, and anybody that's lived in the Houston area for the last couple of decades, if you don't believe in climate change by now, there's nothing that I'm going to say in the next 40 or 50 minutes is going to convince you otherwise. Now, the editor of the AAPG Bulletin insisted, in my original manuscripts, I didn't have anything in there about the science of climate change. But he insisted, you got to have at least one paper in there, or one study you got to reference. And I said, sure, and this is a particular paper, but frankly, all of us, most of us here have science backgrounds. We've had physics or chemistry. And, my opinion, if you put 45% more CO2 in the atmosphere, and we're going down to 100% more than what was here, pre-industrial, isn't the climate going to change? I mean, isn't it just natural? I mean, when I've looked at rocks all through my 35-year career, climate change was recorded in those rocks. You repeatedly saw it. So, it's kind of like seasons. So when you put this much CO2 in the atmosphere, the climate is going to change. But if you don't like that particular rationale, This particular paper is the one that's I quote in my AAPG paper. Rode et al., 2015. What they did, they didn't do modeling, projecting forward. They went back and they looked at records over the last 250 years, land records. Then looked at sunspots and volcanic activity and then temperature change. And what they found was that the best, most simplest explanation for the global warming was the fact that there were more greenhouse gases in the atmosphere. So
G means what?
G is global. So that's greenhouse gas. GHG is greenhouse gas. Excuse me. So the trend in temperature can be explained by the simple response to greenhouse gases. Again, this paper, it's open source. One of the authors, Richard Muller, was an early critic of the Michael Mann's hockey stick, if you remember the graph where temperature goes here, and then with man-induced climate change or man-induced CO2 emissions, temperature goes up. So this was a critic and his team when that did these studies, and was also partially funded by the Charles G. Koch Foundation. So, but again, this is, you can look at this, but my paper has over 70 references in it, and some of the links are hot. So when you download the paper, you can take a look at this reference. And again, this is open source, and it's not a model, it's looking back at historical records. Okay, so again, what I wanted to show was how the petroleum industry, in particular natural gas producers in the United States, can actually be part of the solution of getting to 2 degrees. And so in the COP21, that's the Paris Climate Accord back in 2015, what they were looking for was economy-wide emissions reductions of 80% or more by 2050. That's what's written up here. This is actually from the cover sheet from the U.S. That's intended nationally declared contributions. That's just what they came up with. So this is from the cover page. Other things that they put in there is they have the pledges, which I'll go into the difference between this particular goal and the pledges. And that'll be this right here. So, okay, this is from a recent report, and it's online. You can download it, called The Production Gap. Came out in 2019. A series of research groups here. I can't really spell out all the different organizations that came up with this. But they're looking at what various nations are predicting as far as production. So this is where we're at now, about 2020. This is actually business as usual. This is what the COP21 pledges. So the Paris Agreement pledges. Write that line there. That's business as usual. So we're already projected to exceed the pledges. This is the decline curve, the reduction in emissions that we need to get, and this is at 2040 here, to get to 2 degrees. This is at 1.5 degrees, to get to 1.5 degrees. This is the gap between what's projected, the pledges. So, all right, this is one scenario. This graph is from my paper, and what I did was just hypothetically. So this is from Energy Information Administration plots or projections from 2015 out to 2025. So this is their data that I downloaded. So oil is here, natural gas in red, and coal up here. So this is the reduction curve that I wanted to get to. The reduction from 2005 is what was in the INDC. That was the goal. So 80% reduction to get to here. So all I did was my particular scenario, I started 2025 and just uniformly decreased these very inefficient way of doing it to get down to that 80% reduction. So that curve there is this one right here. Now this is global. This is just for the US, for coal, natural gas, and oil. This line here is actually projections from the EIA projections out to 2050 from their 2017 report. And this would be with the Clean Power Plan or the same as the Paris pledges. This is without the Clean Power Plan or business as usual. Okay, when I started this project in 2017, the only model that I was familiar with was a model that was done by Citizens Climate Lobby. They hired two groups, Regional Economic Modeling, Inc. and Synapse, to essentially model a plan that they had of starts at $10 a ton the first year, and in this particular model it starts in 2015 and goes for 20 years, and you add $10 a ton going out, so that after 20 years it would be over $200 a ton. So this is not doing anything, this is just baseline. So their model showed this. The coal is down here, natural gas here is shown in orange, red is nuclear. This is with the carbon tax starting in 2015, going out to 2035, and you can see coal drops out at about 10 or 15 years. And again, they put these numbers in this model, and this organization has done lots of models. What you see here is natural gas is replaced by natural gas with carbon capture and storage. Nuclear increases, I'm not really going to be dealing with this. Wind really grows, solar grows a little bit. This was really the only model that I was familiar with. So I used that model. So this is the image that I showed before. So this is the graph. This is coal and natural gas, and that's this graph here. So this red is the same as that red. Out to 2025, these are all Energy Information Administration numbers. And then at 2025, I applied the carbon tax using percentages and the timing from this particular graph. Now this was a 20-year modeling projection. I modeled it from 2025 to 2050. And what we have here is I used this to reduce coal, so I used the same timing and the same percentages. This line here is the same as that line there to get to the 2-degree scenario in the future. So an 80% reduction. I'm just looking at natural gas and coal, so this is for electricity. I did not look at oil because all the studies or most of the studies that I've looked at is that a carbon tax doesn't really affect petroleum that much. What really affects petroleum are countries like China, and like the EU and California, saying they don't want to have their cities polluted anymore. They're going to switch to EV or lower emission, high mileage vehicles. And actually, this projection here we see in the 2016 International Energy Agency report. They essentially projected a scenario of petroleum decreasing due to more use of EVs and other rules. But again, the carbon, I'm not looking at the oil, I'm just looking at natural gas and coal in the combination. So over here, they're getting rid of some of the natural gas with this REMI study and replacing it with carbon capture and storage and wind and other things. What I did, now again, this is the line, the emission line, to stay below the 2-degree scenario. So what I did is just replace the natural gas, replace the coal that would have filled this in, and then this material up here is natural gas that you then carbon capture and store the emissions. And I use the same percentages as what's shown here in the same timing levels. And when you all add up all of this gas here and here and here, this line here is business as usual. You actually exceed business as usual. Again, this is a scenario, okay? Now, I think I mentioned over here that this is clean power plan. This is total emissions, the line here. If you go back and look at EIA's projections back in 2017 for the clean power plan, and you look at just natural gas, they also project that natural gas would be consume more than business as usual, because you have to make the same amount of energy. You're getting rid of coal, so you got to produce and consume more natural gas. Okay, now this isn't just a model or a hypothetical plan. Currently, right now, there is, and I'm not sure if I mentioned, but I have been volunteering for a number of years, unpaid volunteered with Citizens Climate Lobby. And their plan of a carbon tax, they want to call it a fee, because they call it a fee because the money comes in, it goes into a trust fund that's emptied out every month, and dividend checks are sent out. This compensates for the higher energy costs, higher food costs, higher every cost that's going to be induced by putting a carbon tax or a fee on it. So this is actually a bill. There are 81 co-sponsors. It's actually bipartisan. There's one Republican. But still, it is actually a bill that's currently in Congress. One thing I'll mention, part of this bill is that they have a border adjustment. And what a border adjustment does is if you're shipping a good out that has a carbon tax on it, you get that money back if it's going to a country that doesn't have a carbon tax. If somebody is shipping something in that has a high carbon content, so it takes a lot of carbon emissions to produce that, then the tax is put on them for that product, and we get to collect the money. So this induces other countries to have a carbon tax. That's all I'm going to say about that particular bill. Now, one of the critiques I had in the paper was, hey, you're just using this non-peer-reviewed study that was paid for by this organization. Sure, they're going to come up with some nice results. So I went back and did more searches, and in the subsequent time from when I started this project, Ross published in 2018, he modeled a $50 a ton tax that started in 2020, went out 30 years. And it increased by 5% every year. And essentially what he shows here, this is coal. It's dropping out more or less at about the same time as I'm dropping out here. This is natural gas existing. This is new natural gas right there. This is carbon capture and storage. Again, it is coming in about like this. Nuclear, solar, all this. This is important. Demand reduction is very important with a carbon tax.
So they're being allowed to pass the tax on to their consumers is the point.
Yeah, you do pass it on. But if you
Bernie wouldn't let you.
Well, I'll get to that. I will show some arguments about pro and con with this. Okay.
Are you going to say anything about the demand reduction? I might have missed it.
Well, I mean, it's all the models show that if you put things more expensive,
Oh, that's what's right. Okay.
people are going to use less of it, right?
I didn't know
Okay.
it was becoming more efficient, hence, but okay.
Well, I'll be going into that, but yes, if you make something more expensive, and so energy use, and energy is about 40% individuals and 60% in industry corporations. So they're going to be looking to make their product the cheapest so they can sell it, and so they're going to be trying to make it more efficient. But again, I'm a geologist. I'm not a modeler. So you'll find that out later on when I look at the next stage of my particular paper. So one thing that was interesting is So this is the same diagram that I showed you. Again, a $50 a ton tax with a 5% increasing yearly. And it is more or less the same as starting at $10 and going up $10 for 20 years or 25 years. He also modeled a $25 a ton tax starting and then going up 5% for the same amount of time, so 30 years. And you can see the coal reduction is not quite as fast. Natural gas is still growing. Maybe a little bit of reduction, but one thing that isn't present is carbon capture and storage, which is here red, and here it's not existent, even though it is in the model. Okay, there was another group, EMF 32 studies. It was 11 teams, 4 scenarios. This is the top one here is a reference, so nothing, no tax. And I think this goes for 30 years. And I'll just briefly, I'm not going to describe all these. The first one is $25 and then a 1% increase during the period, 25 and a 5%, 50 and a 1%, 50 and a 5%. Except for one, this modeler team was really trying to stress coal use and carbon capture and storage. I think this was the only model where it really came in. I'm not going to be going into coal capture and storage. Coal is more expensive now to burn than natural gas just by itself, and when you add carbon capture and storage, it gets even more expensive. And Rubin is a good reference for that, and that's cited in my paper. But in some of these models did not include, let's say, natural gas and carbon capture and storage. But the ones that did include it fit in about the same scenario as what I presented in my hypothetical scenario that I'm presenting. Okay, so what I'm trying to say is that the scenario that I'm presenting is also supported by other models that are peer-reviewed. Originally, I didn't have a peer-reviewed model, but this is not pie in the sky. Okay, there's 2 parts to my paper. The first part was, I propose this carbon tax, and it's going to stimulate more use of natural gas. But then I said, well, maybe if you don't do anything, conditions will get so bad that energy companies will be forced to make changes, okay? And I'm not sure if you're familiar with this image or this graph here, but it's from IPCC 2007, just pointing out all the terrible things that are going to happen as we get warmer, okay? So, as far as plants and sea level rise and things like that. So 2 degrees to 5 degrees. Now, there's some papers that monetize this sort of stuff, but I really couldn't put that into some sort of analysis, and I wanted to do an analysis. So I said, well, let's look at, is there some way to, maybe look at GDP or something like that. And of course, it wasn't my idea. There was a book that came out in 2013 by William Nordhaus, The Climate Casino, and he came up with this model using a dice model. So essentially, according to the model, what he showed was that as temperature rose, global GDP would go down. Now, if with business as usual, it would be as much as like a 6% drop in global GDP, according to this particular model. By 2050, and I'm only looking out at 2050, it would be maybe a drop in GDP of 1.5%. Still, that's trillions of dollars, right? There was another study by Burke, and part of his team was involved in the nationally declared climate assessment, or the National Climate Assessment, 4th National Climate Assessment that came out, I think it was last year. But essentially what he did is he didn't use a model. What he did is he looked at data, I think going back from 1960 up to 2011, and looking at changes the main things we're looking at changes is in productivity with temperature rise. Now, he did this on a national scale. He didn't use petroleum producing companies or petroleum producing or major petroleum producing countries. He didn't use the United States. He didn't use China. But he used all these countries, and he looked at just temperature differences. So not wars or anything like that, but just where you could see a temperature change, and he looked at the drop in productivity. So the top here is in minutes worked, okay? The optimum temperature is about 13 degrees Celsius, which is about 56 degrees. That's natural. We feel like working outside at 56 degrees at least. Well, in Michigan, that would be warm, and here it's cold. But at any rate, you feel good. When it gets up to about 28 degrees Celsius, so that's the high 80s, productivity drops off. So, and then the same thing here, this is how much you can work, and the same sort of thing happened. So what he did was, what his team did, was sort of use that and extrapolate it out to 2100 based on the projections for business as usual, BAU, business as usual with temperature rise. And this is sort of the median. So out here he projects at 2100 if you don't do anything to curb emissions, the drop is going to be as much as 23% in global GDP. Now I'm looking just at, remember my model or my scenario was 2025 to 2050. It would be about 8%. Now you can see the big range here. This is putting all the countries together. So it could be as much as, what is that, about 50% or so drop. But some countries actually improve. And this is sort of a map view. So the higher latitude countries, like Greenland and Canada and Norway and Russia, they're actually going to have a better GDP. And the countries in the low latitudes are going to have a worse GDP. Now remember, this is median 23. So if these are going to be better, then these are going to be a lot worse. So if you think immigration problems are bad now, as the temperature rises, it's going to go an awful lot worse. So, okay, so I used this because it was much more extreme, and I decided, well, okay, I'm not a modeler, like I said. I looked at rocks. Still like to look at rocks, but I looked at rocks for a living. I said, well, why don't I sort of make an analogy with the Great Recession and how that impacted U.S. natural gas and petroleum companies, or production and consumption. So this is the Great Recession. I looked at 2008 to 2009. This is World Bank data. So going from 2000 to 2017, and here is the Great Recession. So globally, it was minus 5.2% drop. The U.S., it was not quite as bad. It was about 2%. I think you remember the Great Recession. So this is globally what happened with oil and gas. Now, the solid lines are consumption. The dotted lines are production. So consumption went down about 1.7%. This is globally. Production went down a little bit. Production and consumption were sort of tracked globally. It's probably natural. Minus 2.8%. But again, this is globally. I wanted to see what happened with the U.S. So this was U.S. consumption. It dropped down 4.8% during the Great Recession. Natural gas only went down 1.8. Now, solid line is consumption. The dotted line is production. And you can see, and those of you that were working in Houston during the Great Recession, we really weren't impacted all that much in the oil patch, okay? We were still hiring the company that I was at. So really we can say that, this analogy doesn't really apply to production. Other things are factoring in. But if we, looked at these drops and sort of come up with, global drop in GDP, So for each drop in global GDP of 1%, natural gas went down 0.4% and oil went down 0.9%. So why am I doing this? Well, if you take that 8 and you multiply it by those other numbers, if oil companies didn't do anything, and assuming there wasn't a war or some other great catastrophe, which probably I think is not really a good, I think that's probably what is going to happen. But if nothing happens and we're just looking at this economically, natural gas consumption would only go down about 3%, maybe a max, if this down here is the line that goes down, maybe 8%. Oil would go down 7 or maybe a max of 20%. So if you're going to go into your stockholders or your investors and go, hey, we're going to voluntarily drop our production by 80% or not do anything, and maybe we'll have a drop of 10 to 20%. What do you want to do? Well, the altruistic people would go, and even if it was majority of altruistic people would go, well, we got to do the right thing. Let's go with the 80% reduction. But there would be a few people out there that would sue, I'm assuming, to not do that. So the point I'm trying to make, and what I showed in my other diagrams, is the other option is you could, with a carbon tax, you could, at least for natural gas producers, you can produce as much as business as usual and not go the route of just, reducing. There is an option, but you need a carbon tax. Okay, now this is something that's not in my paper, and we'll be addressing things like the Green New Deal. So what if a carbon tax is applied? How long before renewables are going to take over? So this is from a organization called Lazard. I don't know if you're familiar with it, but they do, and they've been doing this for, I think, 5 or 6 years or so, maybe longer than that. And they do a levelized cost. So a levelized cost is the cost not only of the, let's say, the fuel that you use, but also constructing and putting all those costs together for the life of the installation, come up with a cost per megawatt hour. So this is $0 to $275. So this would be like rooftop residential solar up here. The cost is about $161 to $242. This has come down in the 5-6 years that I've been looking at this. This is utility scale photovoltaic. So we're talking about in the 30s and $40. This is onshore wind. We have below $30 to up to $50. This is natural gas combined cycle. So base load using natural gas. So already you're getting solar that's competitive with natural gas. This is coal. It's already being priced out. This is nuclear. This is gas peaking, the one you need to fill in. These stars here are, and you can see these are competitive. These stars are already producing plants, including the decommission costs. So these things are still viable. But yes, renewable energy is relatively inexpensive. And with a carbon tax, it's going to even become more attractive. But what are the problems with renewables? So this is from BP, Statistical Review of World Energy. I think this is 1993 here, going up to 2018. This is oil. This is, I think I'm getting this right. Natural gas is in red. This is geothermal or hydrothermal. This is coal. This is renewable energy, this dark orange right here. Okay? So globally now, renewables are only 4%. In the US, it's 4.5%. We have to go from here and replace all of this, and all of this by 2050. So we're already starting from a very small amount. So even if renewables are increasing really fast, it's going to take some time. But they are increasing quite rapidly. This is a plot from a Bloomberg report. So this is going from 2004 to 2010, The histograms, the green, that's investment. The blue line is how much it's increasing. So it's increasing fairly rapidly. After 2010, it's still increasing, but investment has dropped off. And now, presently, investment has petered out. It's still going on, but it's not increasing, but so also is the growth of renewables. Yes, a carbon tax would stimulate this, and that's why we need to have a carbon tax. But what are some other problems with renewables versus natural gas or other conventional sources of energy? Capacity factor. So what is the capacity factor? So like this, nuclear has a capacity factor of 92%. So what does that mean? That means that it can work, a typical nuclear reactor can work at max capacity 92% of the time, okay? Now compared to wind, can produce at max the same amount as this, but it only works 30% of the time, about a third of the time, okay? 34%. So let's say for a period of a year, you need 3 times as much facilities to produce the same amount of energy. Solar, you need 4 times as much. Because here the wind doesn't blow all the time. Here the sun goes down, and in the wintertime you have less sun. So you need 25 or 4 of these to replace that. Okay, so we build more of those. So what are we going to do? Well, we need power lines to move this stuff. This is one way of doing renewable energy. You get wires and you move it around, okay? So this was one study done by May in 2014. And essentially what they did was they looked at to get 80 to 90% renewable energy and to guarantee that during the period that it's going to be produced or supplied to California, or actually this is nationwide, you would have to increase the amount of long distance wires by 56 to 105%, okay? And this actually equates to about 21,000 miles. So it's all that copper, all that steel, all that, hey, I don't want these power lines in my backyard kind of scenario. But that's what you need just to make 80 to 90%, not 100%. Okay, let's say you use batteries. You could use batteries. Okay, we're not going to use wire, we'll use batteries. So Brick and Thornstone did a study of California, Wisconsin, and Germany. And they came up with one of the numbers that really struck in my mind was, okay, so the cost of building the infrastructure to just give I think it was 80% renewable energy to Canada. Now, RPS means Renewable Portfolio Standard. So 80%. The cost of the batteries to supply that are 16 times the cost of the infrastructure, the solar and wind, to supply that energy, the battery cost. Now, this was in 2016, maybe it's gone down, but I don't think it's gone down, 16 times, okay? So batteries are still very expensive. Now this is from the same paper, and please be patient on this here. So what this table shows, so these are the different standards. This is the CO2 reduction, and again, this is from Brick and Thornstone. And this is looking just at California. So CO2 reductions of 50, you have a California 50 RPS, Renewable Portfolio Standard. To get to 50% reduction in CO2, the cost per ton is $42 for each ton reduced. Now the ORPN, that's optimum or optimized, optimum renewable pessimistic nuclear. So $42. Here we go up to the 80 renewable portfolio standard. It really only results in a 70% reduction in CO2. The cost has gone from 42 to 91 per ton. Now, there's two scenarios here that both get to 87% reduction. One is a balanced approach, the balance being a low carbon baseload generation technologies, such as nuclear or like natural gas with carbon capture and storage. So this is baseline. This is not just filling in like a peaking plant. But if you use that combination, the cost to get to 80%, 87% reduction, it's $128. It still goes up. Now this is to get using just renewables, okay, just renewable energy. To get to 87% reduction, you need a RPS of 195. This is that capacity factor that I've been talking about. So 100% RPS, you would think, well, that's 100% renewable. Well, yeah, but to be able to supply the energy, you actually had to have almost 200% renewable energy. So it gets the same reduction. The cost is $300 per ton of CO2 that's removed. So again, this is brick and Thurnstone. It's in, it's quoted in my paper or it's in my poster. Okay, so what I'm saying is one of the ways to get to a balanced approach is like if you have a carbon tax that can stimulate carbon capture and storage, okay? Now, I'm not the only one saying, well, this is economically sound. January of 2019, 3,500 economists, former 4 chairs of Federal Reserve, Nobel laureates, all these folks said, hey, carbon tax is the way to go. And this was in the Wall Street Journal. Now that I've convinced you that a carbon tax is the way to go, I'm sure that you all want to go out there and push for a carbon tax, or a fee, excuse me. Again, Citizens Climate Lobby likes to call it a fee because it's revenue neutral because the money doesn't go to the federal government. It goes in and goes out. But I've been using the tax, so that's what I'll keep calling it. I want to just mention a program. It's called En-ROADS. It's by Climate Interactive. One of the groups is MIT, Sloan, anything with MIT is cool, right? So they designed this. They actually, I have a chart in my paper. I use C-ROADS. C-ROADS was used by nations at the COP21, the Paris Agreement, to sort of test their models or, you know, are they getting their reductions low enough? So these folks have been around. Well, they came up last January, very new, hot off the press, and you can actually, so if you want to write this down, En-ROADS, and you can Google it, and you can find this, and you can go play with this. And what does this thing look like? Well, this is kind of like the front page, more or less. These are different energy mixes. This is not really their display. You can change all these graphs. There's a whole bunch of graphs that you can change. Different energy types here. This line here are the temperatures. So this is business as usual, 4.1 degrees. Business as usual is in black. The current scenario is in blue. Now you have all these little sliders here. So you can slide new technology, renewables, you want to stress those. You can put in a carbon tax. And in fact, you can actually, each one of these is kind of like ArcGIS if you worked ArcGIS. You can see a map, but if you click on it, there's something underneath it. And there's something underneath all of these. So you can actually go in and you can put in a carbon tax. And I went in, not using the slider, but actually going in and putting in the carbon tax that I was talking about. And lo and behold, what do you get? Oh, we're not at 2 degrees, we're at 3.1. So you can get 3.1, still it's a degree drop. So that is not a silver bullet. I think what the originator of the En-ROADS, or one of the big honchos, he likes to call it silver buckshot. This was a big pellet, okay? So you can add other things. So this is one thing. I sort of went in and sort of increased regulations on methane. So I just went halfway. I didn't come up with bovine plugs that plug all the rear ends of cows. I just reduced maybe, just reduced methane about halfway. That dropped at about 0.5 4 degrees Celsius. So that methane and getting a handle on methane leakage, because we know the radiative forcing of methane is 100 to 10 to 100 times that of CO2, but CO2 stays in the atmosphere a lot longer. But I mean, I urge you to go in and you can check this out yourself. Now, not to say, well, then the carbon tax doesn't work. If you add all these other things, stressing renewables, and this is transport, energy efficiency for transport, for buildings, maybe 50% electrification, technology. So like some of the technology here would be taking CO2 out of the atmosphere. So one of the things, and that shows up on this graph over here, below the 0 line, right there. So we put on a carbon tax or fee or whatever you want to call it, and we stimulated carbon capture and storage. Well, now we can have bioenergy, grow plants and then burn those, and then we can stuff that underground, okay? More jobs for geologists to find new places to put this stuff in. So that would be part of this negative emission technology over here. But again, I urge you to go check things out. Now, this is just one example of afforestation. So just max out afforestation, which would equate to about 2 times the area of India. I could call this the trillions of tree plan. I think some folks have come up with that plan. Well, what does it do? And again, not only are you going to have to plant twice the size of India, you're going to have to displace all the farmers that were on that land. But at any rate, what does it do? According to this model, it only gets us down 0.1%, or 0.1 degrees Celsius. So maybe there's something that's a better bang for the buck than planting a bunch of trees.
But that can't be possible. And the biomass uptake is much more than the excuse my, but we have 36 billion tons of CO2 being emitted through fossil fuels, and the uptake of the Earth is around 200 billion. So, I mean, that model cannot be right.
Well, I would. So what you can do is when you go back, you can actually go in here and you can click on this, and it'll take you back to the innards, and it'll give you all it'll actually list the papers that it's based on, and it'll give you the models, what the data is that they're using. And I really can't argue for or against what you're saying, because I'm a geologist, I'm not a forester, and I'm not a modeler. But this, again, is what this thing projects. It says that trees are going to help, but it's a very small component. And the other thing, like new technology, and the arguments, again, you can go in and look at this model. I urge you to. Again, it's open source. You can go in. You can't download it. Well, you could download it as long as you don't turn your computer off. But you really need to be online to do this. There's like 14,000 calculations that go down every time you move one of the sliders. So, but again, I would urge you, and they're more than happy to interact with you if you don't like what they're promoting. And they've tested this against a lot of other programs. But I'm not really here to promote this program. I wanted to just show you one thing, and I mentioned, as far as bang for your buck. Now one of the things that I did do is, okay, so this was a scenario that I already showed you. This is with the carbon tax. You can also do a cost, what's going to happen. So this is the cost of energy. And this is with the Green New Deal, assuming, if you read the Green New Deal, it says we're going to get rid of fossil fuels in 10 years. So what I did is I went in, I got rid of fossil fuel use, and I'll have to admit, this is globally. This is not for the US, this is globally. Okay, so this is the cost, and I'll make it. So this is a blow up, this is the carbon tax, and the scales here are different. This is in dollars per gigajoule. The top thing is $45. The top here is $80. So I went in and so you can also download this and put it in an Excel spreadsheet. And then you can play with the numbers and see what it does. So what I did was I took these numbers, multiply, you can also download, you can also get the energy use. So the amount of energy or consumption. So you multiply the cost times the consumption. I looked at 2020 to 2050, and I call this a comprehensive plan with the carbon tax. The Green New Deal would cost twice as much. Oops. What happened here? It's something, okay, go to the next one. Okay, so one reason why I did this is excuse me, I'd read a paper by Paul, 2015, and he did an analysis looking at two types of renewable portfolio standards, or essentially regulations, compared it with a carbon tax and with cap and trade, and getting to the same point, the same emission reduction. And essentially what he came up with, or what they came up with was, let me go in the right direction here. Oh, there we go. Oh, I forgot that the conclusion was up here. It was, again, the regulations cost about twice as much as a carbon tax. So the carbon tax is cheaper by far than just doing it with regulations. Now, one thing, like with the Green New Deal, if we go back for a minute. Now, the Green New Deal has many, many aspirations about they want to do things like just transition, so taking people that are displaced from their coal or their oil and natural gas jobs and, helping them out, or maybe free education. And, well, if they're throwing money away on their emission reduction plan, I don't think it's a good idea. So.
That $5 billion lubes a lot of votes.
What?
Bernie that's one of the few things that Bernie got very specific about, was a $5 billion set aside for retraining, mortgage payments, utility payments for all the displaced workers. That $5 billion lubes a lot of votes.
Well, what I'm saying is that, why throw the money away on a plan that, costs more than it should? So if carbon tax, again, I'm not a modeler, I'm basing this on what I've read and the analysis that I presented today. Okay, so my conclusions. The U.S. natural gas production could exceed business as usual, so business as usual is 3 times the proven reserves that we have now. So even exploration geologists get to keep their jobs because they need more natural gas, okay? And we're still getting to stay below 2 degrees. A high carbon tax is needed, though, to significantly, to incentivize the use of carbon capture and storage. Now, if you want to contact me, Rubin et al., I think 2015, he gives the analysis of how much it costs to produce energy with carbon capture and storage versus a regular way. So those were the numbers that I was using. A balanced approach with natural gas and carbon capture and storage is a cheaper way to get to 2 degrees. And the reason why I wrote the paper and the reason why I want to stimulate conversation, what do they say? If you're not at the table, you're on the menu. We should really be talking. We should not ignore the fact that the climate is changing. We can be part of the solution, okay? Or we can, just ignore it. But I'm not sure what we're going to tell our grandchildren if we do that, okay? So that's what I had to say. Thank you for your time. I'm happy to take comments, but I need a glass of water. So thank you.
So after Jim gets his water, we'll take some questions. I see if Linda's right on it.
Thank you.
So the disconnect for me is the inability of the United States to control the rest of the world's attitude towards burning coal. So you can slide bars back and forth on a program all the time, but that big fundamental problem is if you are only doing it to the U.S. or maybe Canada or the other Western Hemisphere involved, the big elephant is China, India, and they're really unresponsive to whatever pleas we have on our own.
Well, I mean, actually, they were slowing down and then they're starting to increase. So, but yes, you're right. But with the bill that's proposed, and it's not the only other bill, that has a border adjustment. So what it does is, if China produces something and doesn't have a comparable carbon tax, then we will put a tax on their goods that they ship in. And then on the other end, if we ship something out to a country that doesn't have a carbon tax, the carbon tax will be taken off, or fee, or whatever you want to call it, and given back to the producer. So that does not hinder our producers selling in that particular country. But if they're shipping things into our country and we're putting a tax on it, we get to collect the money. They don't. So eventually, hopefully, that will incentivize them to put their own carbon tax. But we're all on the same ship together. We historically have been the biggest emitter. We're the number 2 emitter because I think one of the reasons is we've shipped all our manufacturing and our emissions to China and other countries. That's one of the reasons why we've gone down, because we're not manufacturing here anymore. But, you know, that's, if we don't do it, we're number 2, why should anybody else do it? We're all going to go down on the same ship, or at least our grandkids are. So, yes. Did I answer your question? Or I know it's true, but if we don't do it, we got to, and I think one of the problems is, and here's one of the things like with drawing back money. So before Obama left, it was like a 200 billion, I think, I don't know the number, I know it was in millions, of going to countries, developing countries, to help them lower their emissions. But we stopped doing that. Well, they weren't the historical emitters. They really should get help. And actually, maybe dollars that go to a third world country to maybe do renewables versus coal is going to help. We're all in the same atmosphere, so that might be a bigger bang for the buck than spending more money on renewables in the U.S. But that's just a sidebar. Yes, sir.
How do you apply the tax? You mentioned like when a barrel of oil is produced, the CO2 content might be really high, but most of that might not be emitted into the atmosphere unless somebody burns the tires that are a result of the refinery process. So at what point of the supply chain do you apply the tax?
That has not been specified in this particular bill, and the bill is going to be, even if it was passed the House, it wouldn't go anywhere in the Senate. But that is a point of discussion, and there's groups that are discussing that. But like the lock meter, where that's probably might be a good place to assess, you know, where you're getting the volumes of natural gas or oil produced from a well, would be a good place to apply the tax. They want to, sort of the general thing is from the mine or the well or the place where the port that it comes in is where you would apply the tax. Now, where the money would come back if you're sequestering it, I don't know how that would all revolve, because the added money would be put on, like I said, as close to the well or the mine as possible. But that is not in stone in the particular bill. Did I answer your question?
What is the equivalence? Like, for example, a barrel of oil equals how many tons of CO2?
Well, it's about, let's see, coal is the top, and what is it? Oil, and I should know my numbers now, but I can't pull them off the top of my head. Is it about 80% of coal, and the natural gas is about half? So if you were to consume it, this is just relative percentages. So I can't give you the ton. It's in the paper as far as how many parts per million equals a gigaton of emissions. But coal is the dirtiest by far.
What I'm saying is I don't think you can do it with oil. You can do it with gasoline. I've always heard 100 gallons of gasoline equal a ton of CO2. But a barrel of oil, most of it goes unrefined or refined into tars that are put onto roads that don't go into the
And
atmosphere.
and they haven't worked that out. So this bill, the bill that I talked about, is like 43 pages. It doesn't go into all those details. And I'm sure if and when it is passed, and hopefully it will, some iteration of it is, there will be all sorts of committees that will come out with all those different rules about whether it goes into plastics or whether it goes into asphalt, and emissions, and each one would do that. But there are lots of, and I have not read all the rules. There are many rules that look at like imports and classifying pork bellies and all this. There's folks that do that, and I have absolutely no idea how they come up with them, but people do that. Scott.
Society of Petroleum Engineers has a study group. American Petroleum Institute is already talking with A, the Fed, and B, with IPAA and every senator that will sit there and listen about exactly your points. How to get an equitable distribution of feeing, if you will, onto what portions of the hydrocarbon droplet or the hydrocarbon barrel. It's not all, oil doesn't turn into power plant fuel. Almost all of our liquid hydrocarbons turn into transport fuel, totally separate issue. So there's a lot of build out of legislation that is going to take 10 years before any of this happens. So I think Jim's done a wonderful job to give us a nice equitable baseline for a lot of points of discussion that I think we need a Scott Tinker slider in there. I don't know how many of you had a chance to attend his switch.org presentation at the Wortham this past week. Really fantastic, and it highlights exactly Linda's observation that, China, fill in the blank, Nepal, Colombia, Kenya, all the places that Tinker went to. They want and need more. Vietnam, they all have lots of coal reserves. They all want local production to employ local people and have local revenue. And that's what's really causing the coal and the coal plant construction increase, is not just, hey, we want to mess with the environment or we want to undo what the US has done. They want local revenue, and that is a driver that just overwhelms it all. I talked to Dr. Tinker for 5 or 10 minutes, which for his schedule was a lot, about exactly that after the presentation was over, and he said, it's nearly intractable. He said, everybody has a lot of good goals. Paris was wonderful, but he said, really getting these people to live through building those 274 Chinese coal plants and getting out to the other side. He said, if we just gave them LNG, it might keep it from happening. But he said, they still need to have people work. They still, want to utilize their own resources, and it's not, there's probably an element of national pride in there, but when Tinker made his observations, I'm just a geo who reads. He's the guy who's lived there and walked there and, made the movies and all that stuff. And when he says it's intractable, there's a lot we can do. And I think a lot of ways that we could lead. Like Jim said, if we succeed in putting taxes on, but the taxes hit our consumers first before they convince the producers second.
Well, again, I've had these conversations with some of the groups in Detroit and around, so the environmental justice groups that represent low-income people. They want affordable energy. Well, I said, well, if you give money back, if you made all energy affordable, the rich people
environmental justice people want affordable energy.
right, they want affordable energy.
Yes.
But they're the ones that are also catching it in the ear because they're usually the ones that are right next to the refineries or the coal power plants and things like that. But they want affordable energy, so I said, well, isn't that giving money back? I didn't get an answer to that. But the thing is we've done not a lot of studies, but there have been some studies that the lower 60% would get more money back than they would spend in increased costs. I think that's mostly in the early years when we're talking about $10, $20 a ton. I don't know if that plays out when we're out to $100 or $200 a ton. But there are numerous studies, and I didn't quote them here, but that look at a carbon tax is an equitable way to do it if you redistribute the money back to, especially in this particular bill, you actually get a monthly check or a self-deposit, in your account. So
And that's per capita.
it's per legal resident in the United States.
Citizen,
Yeah.
And-
Yes, Jim.
and I think we're seeing that what Jim hoped was that there'd be a discussion we're having here. Can you go back to your, when you were playing with the MIT models, and while you're doing that, at least when the REMI report came out now 7 years ago or so, the impact, as an example, consumer impact, was about 2 cents per gallon on gasoline, which is, something we all look at and measure. So in that case, it's the difference between driving around shopping for the best gas price a lot of times.
So did you want this or
So
back to
all
Remy?
of them except the afforestation do have you do hit a 2-degree target at about 2050 with all of the cases you ran, except for the afforestation.
No, even with the carbon tax, you're not.
And then some of them do continue to increase, and you've got 1 or 2 that level out. So the 2-degree is conceivable with several of the scenarios you did, and in fact, it can be flat as in that case.
Well, again, what you're doing here is you're doing technology, and I could pull up the Green New Deal. I call it the Green New Deal scenario, where you're cutting out coal and oil and natural gas within 10 years, but you got to do a whole lot of other things. It's possible, but again, and I'm not an economist. I just played with this very simple tool, and it sort of works when it's the same. It comes up with the same answer as these peer-reviewed studies that were done by people that do this for a living, that it's much more expensive to go with just regulations than with a carbon tax. It doesn't seem like that would be true, but what you have to do, it's called a Pagovian tax, so you put a tax on something to sort of channel people to do something, to do what they should do. And if energy is cheap, they're going to use more of it. Yes, sir.